Hello, good day all. This is Steve Abelman. I'm a customer success rep and longtime aviation weather subject matter expert with the Weather Company, and I'd like to welcome you to our third episode of our podcast series from the Forecast Desk. We've already talked about winter weather precipitation types and turbulence in our first two, and today we'll shift into another impactful aviation hazard and challenging forecast topic, all about fog, low clouds, low visibility. Now, we know throughout the aviation enterprise that fog impacts are very expensive, delaying flights, causing fuel burn, adding complexity at airports with higher lander minimums. And especially in the commercial sector, we know when the visibility drops or when low clouds form, airborne acceptance rates, affectionately known as AARs, may drop with it. A airport that can handle 60 airplanes an hour may only be able to handle 30. And the difference between an on-time performance and a gridlocked morning often comes down to predicting the exact minute the marine layer will shift from the airport back over the open water, or when the RVR comes up above a critical threshold. So today we'll discuss improvements to fog and low cloud forecasting and how TWC helps our customers keep their operations safe and efficient. Today, we have two senior aviation meteorology forecasters with us to discuss this, and let me introduce you to Keith White and David Inmon. Keith.
Hi, I'm Keith White. I'm an aviation meteorologist with the Weather Company, embedded within a large commercial carrier. And I've been here for just over a year, but I have about 15 years of experience in the atmospheric sciences, wide-ranging from government forecasting to research to both the public and the private sector. So I bring quite a breadth of knowledge to this position, and I'm excited to be here today talking with you about how fog impacts airline operations.
Great, thanks.
Okay, my name is David Inmon, and I also am going on my 15th year of aviation forecasting experience. I work for a large cargo airline, support of cargo airline. I just celebrated my year anniversary with Weather Company yesterday, as a matter of fact. So, but I have been in support of the same airline for and worked for them 28 years prior, and again 15 years in aviation forecasting. And one of the largest expertise areas that we have at this airline is fog forecasting, and we've been on it since the mid-90s as an airline. So I look forward to sharing myself. So
great, thanks to both of you. I think we have clearly the experience level covered here that we need to talk about this topic. So I'm going to ask you guys a few questions, and I'd love to hear your insight on a couple of things. And so one of the challenges we know is, when will fog lift? When will the fog and stratus lift? So if we forecast a 9 a.m. burn off time and it clears at 8:30, the airlines may have scheduled unnecessary delays and capacity reductions. On the flip side, if we say it's going to clear at 8:30 and it doesn't clear until 9, there may be excessive holding, diversions. So how do you refine that timing down to the minute?
Well, I'll go first. I believe the first and most important question with any fog, either forecasting its arrival or the dissipation of fog, is to know what type of fog you're talking about. Are we talking about the two main types, radiation versus advection? And there's different ways to forecast when those up times are going to come up. But the main ways to forecast those up times, you have to know how thick the cloud is above the ground level and how close you are to the edge of the fog bank. Ground temperature is important. Sometimes it's simple as getting the sun to come up, because there's really only two ways to dissipate fog, and that's either you have to warm the cloud or you have to dry out the cloud once it forms. So fog typically forms, in most cases, especially with radiation fog, which covers about 80% of all fog, it forms under areas of high pressure for the most part. So you're talking about low wind situations, clear skies before the fog sets in, and really nighttime radiation fog forms at night, and it starts to lift when the sun comes up. So any way you can warm that fog, sunrise itself is usually one of the main ways that you're going to lift radiation fog. But ground temperature, if it forms over a warmer ground temperature, the radiation net input from the ground itself can actually warm and lift that cloud into low stratus. Summer, winter, when you're trying to forecast a fog up time, generally the rule is 200 feet. For every 200 feet above the ground level, you add on another hour for your up times on that. And then for about every 15 to 20 miles that you are inside that fog bank, then you add an extra hour-ish to the up times on that as well, when you're talking radiation fog. Now, if you're talking advection fog, that gets to be a different beast, especially if you're talking warm advection fog and marine layers and things like that. And that can go much farther into the day, but you're really looking at cloud depth as your number one probably indicator. And then you get that depth from all sorts of different sources, PIREPs, observations, soundings. You try to identify where the top of the boundary layer is and the inversion level and things like that.
Interesting. Very interesting. Thanks.
Right, and if I can add to that, it's similar for both fog and low stratus. I forecast regularly for San Francisco Airport, where most days in the summer they're dealing with stratus clouds, and because of the way that airport is built, they have two parallel runways that are very close together. And if the skies are clear, they can run dual operations, land two planes at the same time. If there's clouds below about 3,500 feet and the two pilots can't see each other or can't see the people in the control tower, they have to lower that acceptance rate. So it becomes more and more important for us to let our controllers know, when is that cloud base going to clear out so that they can have visual approaches. Overnight, you're mostly looking at model data and trying to concatenate all of the available information and get a first guess of when that clearing is going to occur. Once you get later in the morning, the models get you that starting point, but observations are going to help you with the details. Once there's planes taking off, you can look at the ACARS sounding data, or we also have a balloon that goes up every morning from Oakland. You know that thickness, and like David said, 200 feet every hour approximately. There might be some adjustments to that if there's higher clouds limiting the radiation coming in, or other factors that may play in, but you'll be able to refine that clearing time. And you might not be able to get right down to the minute, but you can get close enough that your airline operations are prepared for, within about ideally 10 to 20 minutes of, when they'll be able to get those rates up and stop holding. In the meantime, they're prepared usually with extra fuel. But once you have that observational information, you can get those details as close as possible.
Great. Thanks. Interesting. So anything else you look for in your analyses or your numerical model predictions to help you hone in on the accuracy of fog forecasts? Are the models getting better now? Are they really helping you out?
I think they can be certain models, especially your short range models, especially with radiation fog. You need to know what the temperature was that fog formed overnight, because you want to get back to that temperature, because that's really your initiation point. So if, say, I have an airport that fogged in at 50 degrees Fahrenheit, it dropped down to 45, I want that temperature with the sun coming up and other factors to get back up to 50 degrees. So I'll look at things like some of the government models that go hour by hour or things like that with the numerical models to see when that temperature is going to get back to its initiation point. And then observations are key, and satellites are key indicators as well, especially if you look at tools like the nighttime microphysics satellite. You can see that radiation fog a lot better than we have been in years past. And so that's a few of the things that we look at here.
To add to that, you can use a ton of other tools besides models, especially once the fog has already developed, in order to help you determine that fog clearing time. One tool, for example, is radar velocity, like wind profile data. The radar is not going to show you a wind if it's not detecting some sort of particle. So once you get to the point where there's no wind showing on the radar profile data, you know that's the top of the cloud, and you can estimate that fog thickness to help you get as close to the clearing time as possible.
Great, great, very interesting. Now, I think we covered a little bit about different types of fog. I know, David, you covered a little bit about radiation and advection fog, and I guess sea fog and steam fog. Anything else to add on that topic about the different types of fog?
I think one of the major keys would be that sometimes two fogs sometimes you can have radiation and advection fog. So you can have perfect radiation fog conditions, but with a very slight upslope, for example, or a marine layer that, especially like on the northern Gulf Coast, where you have a very light southeast wind, say into Lafayette, Louisiana, and you have perfect radiation conditions and just this weak marine layer that's coming ashore as well. And then the two can combine a lot of times to make a fog situation even worse with lower visibilities that can last a little bit longer. We see it up in Anchorage all the time. Perfect radiation conditions with cold advection fog, and then you have the tide comes in, because the tide in Anchorage runs about 20 to 25 feet different between low and high tide. So you have this enormous amount of water coming in too, just kind of increasing the moisture. So there's a lot of variables that go into the different types of fog, but that's one of the things you have to hone in on sometimes, is that sometimes different fogs can work together to exacerbate a situation.
Right, right.
And oftentimes they'll be looking for different things when you're trying to figure out a clearing time for a type of fog. An advection fog is by definition moving with the wind, whereas a radiation fog is often going to be improved by the wind mechanically mixing drier air in at the top of the fog layer. So you're definitely looking for different mechanisms for improving that fog depending on how that fog developed.
Great, great, thanks. So one thing I want to especially, talk to David about. So we know that some of our cargo customers, for example, operate at airports, with different restrictions. Can you give me an example of these and how that plays differently into the way you watch the weather at these airports?
It does play in. We do have a lot of what's called Cat 1 and Cat 2 airports with higher landing minimums. Up to, say, you have to have 2 miles, or you have to have for the cruise a decision height of, say, 500 feet, where basically you can't have clouds below 500 feet or visibility less than 2 miles. So we have a lot of these airports because the cargo carriers will go into a lot of smaller airports. A lot of these smaller airports, even though they have higher landing mins, are in smaller, maybe more rural areas. We're not talking about your huge, large urban heat island airports. So they're going to have more radiation fog sometimes, or typically will. So we run into those problems all the time. We have to forecast. Say if I'm looking at a Cat 3 airport, I might be focused in on Cat 3 landing minimums when I'm doing my fog forecast every night, because we put out nightly fog forecasts for the airlines. If I have a higher min airport, then I'm looking at maybe visibility or ceilings going below our landing minimums. We have kind of cheat sheets, if you will, which airports have which landing minimums, and we forecast accordingly. So we're not just doing a standard, say, quarter mile or below forecast. It's very airport dependent. And then they'll make contingency plans around what we give them and adjust accordingly.
And Keith, you have some examples too, don't you?
Yeah, so it's not necessarily just an airport to airport difference. It could also be plane to plane or pilot to pilot in terms of the ratings that they are allowed to fly into. So, say in Houston, for example, hub to hub flights, international flights, most of them can fly into quarter mile fog safely and efficiently. But those smaller regional jets that are getting people to the bigger airports to connect them to those bigger flights may not be able to land in those conditions. So they're keenly looking at the forecast when we may have a risk for those quarter mile or less visibilities and making determinations on whether or not to delay flights based on that.
Yeah, very good, very good. A lot of little nuances here that are fascinating to me to hear how you both are honing in on those different nuances for our customers. I think that's really critical. So, one final question. And we know unforecast fog happens, and that's probably more problematic than when we forecast it accurately. So help our customers understand how TWC is monitoring changing conditions and keeping our customers updated and our products current.
Absolutely. So the weather company has a team of meteorologists across the globe. We have teams in the UK and Asia and several teams here in the United States that are working around the clock. Even in the middle of the night, there are still dozens of meteorologists around the world actively monitoring all of the hub airports that we're forecasting for, keeping an eye on where fog might be at risk of developing or where it's already developed and may spread to. As soon as the forecast changes from what is out there to our customers and to our partners, we're updating them in real time, as soon as possible, and keeping them both aware of what the probability is in the forecast, but also the possibility, the worst case scenario, and that way they can plan accordingly and ensure safe operations.
Thanks, Keith.
I think here at our airline, we've really kind of considered ourselves experts in it since the previous crew that retired in the mid-90s. But when we see something come up, and there's little clues that you can pick up on too with satellite data and things like that, but we're constantly monitoring. We call it, weather watching, and we don't want to be surprised by anything. So if, for example, you don't always get it, but say at Boeing Field in Seattle, that's where we discovered it first. You can get little clues when the fog bank is moving in on the observations. You'll get like, say, few or scattered at 200, and that's usually like a big uh-oh on a radiation fog situation, because the boundary layer is starting to saturate, and you look at the satellite, and sometimes you can give the people at the airlines a heads up, but that's really it, though, is we kind of pride ourselves in being proactive. Even say if we haven't forecasted it on the fog list the night before, when we're watching it overnight and in the morning, we want to run and communicate to the decision makers at the airlines immediately when we see a concern. And communication is really the key when it comes to alerting your airline of potential problems.
Yes, thanks. Thanks, both of you. I want to add something that I've been working with lately, specifically, and that's FOD, or our forecast on demand product. And FOD provides 1 hour forecasts of nearly all the impactful aviation variables, including fog, visibility. And FOD comes from a TWC proprietary ensemble of models. And it's really neat because it's updated every hour. And, our customers can access this data a variety of ways through our, primary product offerings, such as the Fusion or Maverick Dispatch, or even our Pilot Brief Optima tools. But it's also available via API. And so a lot of our customers are using this data via API. They set alarms and alerts when these trigger, thresholds. And so it's really becoming and increasing our popularity. So I wanted to add that. Well, that's the end of my questions. I want to turn over to both of you for some closing remarks, some brief closing remarks, and thanks again for both of you being here. And I'll turn it over to you. Give it a shot.
Sure. Yeah. So, as we've discussed, fog can have significant impacts on airline operations, but with due diligence from our team of meteorologists and the tools we have available and accurate forecasting, we can minimize the risk to the airlines. Minimize the amount of flight delays, the fuel usage that they're going through, and enhance public safety all in the process.
Thanks much, Dave.
Yeah, thanks, Stephen. I couldn't have said it any better, Keith. We try to get ahead, and basically the key is kind of a phrase in our office is be proactive instead of reactive. And we just want to communicate any concerns, especially with the cargo airlines. It's a little different than the commercial guys, where we can actually put in maybe some different contingency plans and things like that when you're not carrying passengers, so they can split flights, they can do other things to work around the fog to minimize some of those fuel costs and other problems. But the bottom line is we want to let them know any event beforehand, and we want to pay attention to those alarms for any of the unforecasted fog that you mentioned as well. So
super. Well, I want to thank both of you, David and Keith. Great discussion. And that concludes our podcast today. We'll talk to you next month. Everybody have a great day.